Yes, dear students. Now, today I am telling here about Maxwell displacement current. Ampere's circuital law tells us that when a current is being passed through conductor, a magnet will produce around it. Now, if we consider this parallel plate capacitor, which is being charged by battery and current at an instant it. So during charging process, a current will be there here, and if we consider point P at distance r, and apply Ampere's circuital law, we find magnetic field here given by integration B dot dl equal to mu 0 I. Here I is the total current passing through surface S1, this circular face S1. Now, but now if we consider that this loop enclosed surface S2, which is partially outside the capacitor, partially inside, since there is no current, if we consider surface S2 enclosed by closed surface, by closed loop C, which is partially inside the capacitor and partially outside. Then integration B dot dl is equal to 0. No current is passing through S2 because while capacitor is being charged, no current flows through the capacitor, because since no current flows through the capacitor, when capacitor is being charged or discharged, so what I mean, तो इक्वेशन 1 क्या थे हमारी इक्वेशन, B dot dl mu 0 I. If I, then there is magnetic field at P. Question is of finding the magnetic field at P. This equation tells us there is field. While this, if there is no current, then no magnetic field. So this is called inconsistency in applying Ampere's circuital law. Equation 1 telling us here that there is magnetic field. Equation tells us here that there is no magnetic field. जबकि field तो है. Then how to remove this inconsistency? Actually, I is equal to 0. Make this inconsistency. Maxwell pointed out. Maxwell pointed out. Pointed out. It is 1864. In 1864, yes. That when capacitor is charged or discharged, there exists a varying magnetic field. Varying electric field. Varying electric field. Varying means varying with time. Varying electric field. I should write here time varying. Time varying magnetic field exists there. This time varying field, why it will change? By if there is a capacitor having charge Q and minus Q, electric field is equal to Q upon epsilon 0A. If Q is changing with time, when capacitor being charged, so current keep on changing, because when capacitor gets fully charged, no current flows. So this time varying electric field So this time varying electric field, Maxwell told that this time varying electric field is equivalent to an electric current. And he named the current Maxwell named this current as displacement current. And is given by ID, this stands for ID, epsilon 0 d phi e over dt. Here phi e is the electric flux. Phi e equal to E into A, and E equal to Q upon epsilon 0 A or into A. So A cancel. So ID is equal to here epsilon 0 Q upon epsilon 0 A into क्या भाई ID epsilon 0 और D upon dt हो phi e q upon epsilon 0 a into a cancel, so it is epsilon cancel, it is dq over dt is equal to I. Whatever this current is there, the same is inside it. Displacement current is equal to conduction current, and therefore Ampere circuital law, equation 1, can be written as so equation 1 can be written as integration b dot dl is equal to mu 0 I plus mu 0 id or mu 0 I plus mu 0 epsilon 0 d phi e over dt, and this equation is called Maxwell Ampere circuital law. This equation is called Maxwell Ampere circuital law. Or generalized Ampere circuital law. Ampere circuital law. So now we come here. This displacement current is distributed over the whole surface, whole space, while conduction is confined in the wire. So magnetic field produced here near the wire may be much stronger than the magnetic field of displacement at the boundary of the capacitor. But if we think there is point M here at same distance from the axis, then the two fields are equal. And actually here this Maxwell Ampere circuital law has become consistent, and we can write like this I plus mu 0 id. But where is conduction current, there is no displacement current, and where there is conduction displacement, no current. So equation तो continue होगी, but the displacement current and conduction current are not continuous. Discontinuous तो है current. यहाँ पर conduction तो नहीं होगा, यहाँ displacement, तो they are discontinuous. But we come here that the displacement can produce magnetic field. It may be same at same distance from axis, but if we think that field here and here are different, because the displacement can be distributed in the entire space. Okay, now see here one thing more. If I consider here another figure, charge Q at an instant here, so electric field is this way. If I consider a loop here, then magnetic field is a long tangent at every point, and the electric field is cross, means left to right. So these fields are existing there, electric field as well as magnetic field, which are perpendicular to each other. This time varying electric field, this is called time electric field, produce this magnetic field B. Together, there is empty space or maybe some perfectly insulated. In our NCERT book, we are told here, in general, we suppose that displacement, this electric magnetic field have existing together, and conduction current and displacement current may exist together also, because there is no perfect bad conductor and no perfect good conductor. So we get the idea here, okay, varying electric by हमारा जो बायट-सेवर्ट लॉ है या जो बायट-सेवर्ट लॉ या एम्पियर मैक्सवेल लॉ, तो कहता करंट प्रोड्यूस मैग्नेटिक फील्ड, करंट produces magnetic field. But Maxwell pointed out that varying electric field also can produce magnetic field. And in one which is called Faraday's law of electroinduction tells us that we can induce EMF by a time varying magnetic field. Faraday's law states that we can produce induced EMF, or induced EMF is a potential difference, and where is potential there is electric field. So that way, I have proved also, told you that time varying magnetic field produces electric field, and time varying electric field produces magnetic field. So they produces since electric field, magnetic field can exist in vacuum. So if any varying vacuum we produce a varying magnetic field, then a varying electric field will be there. And if the electric magnetic field are changing, and I told they will be perpendicular to each other. So these time varying electric magnetic field are a type of wave. Yesterday in previous video I told you what is wave. Wave, I told you, a variation of any quantity produce wave. There are so many meaning of wave. When you are saying goodbye to your friend, you are waving your hand, this is also wave. When we drop a stone in pond of water, position of water oscillate to and above and below and along horizontal direction also. So that change of position or change of any physical quantity is wave here. And that way the concept of electromagnetic, actually the wave which consists electric field, magnetic field, which are varying with time periodically, produce electromagnetic wave. So this was theoretical idea given by Maxwell. These time varying electromagnetic field are producing electromagnetic wave, and later on he proved the light wave are also electromagnetic wave. But electric field, magnetic field here should be varying. Static electric field means if electric field is not changing with time or magnetic field is not changing with time, that is not wave. वेव तभी होगा कहीं भी जब कोई भी फिजिकल क्वांटिटी वेरी कर रही होगी. यहाँ पर इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड वेरी कर रहे हैं. यस डियर स्टूडेंट, आई थॉट यस्टरडे के यू मे नॉट अंडरस्टैंड व्हाट इज द पीरियोडिक वेरिएशन कैसा होता है. पीरियोडिक, यू नो, in trigonometry sin theta is a function y equal to a sin theta. If there occur a change of sign, suppose theta is this. If we are rotating this position vector like this, then we have turned through angle 2 pi. So 2 pi plus theta again sin theta. So after every change of 2 pi, there we get same value. Similarly, you have learnt in chemistry also that physical and chemical properties of elements are the periodic function of their Mendeleev told mass number, Moseley told atom number. After every eighth element, we get the same property. So that is periodicity. Period may be of time, period may be of number, period may be of distance. In class, school, period, first period, second period, after every 35 minutes, bell rings and we get another period. So periodic variation in any physical quantity produce wave. Here electric, varying electric magnetic will produce electromagnetic wave. So first of all, Hertz proved practically we can produce. I will tell you. So पहला some properties of electromagnetic wave I will be telling you in next video. Maxwell proved this thing, and then he wrote 4 equations of electrodynamics, electrostatic and magnetism, which are called Maxwell equations. So these 4 equations are called Maxwell equations. Maxwell's equation. नंबर 1 तो है आपकी इंटीग्रेशन E डॉट डी एस, सरफेस इंटीग्रल ऑफ इलेक्ट्रिक फील्ड इक्वल टू Q upon epsilon 0. दिस इक्वेशन टेल दैट जैसे Gauss law in electrostatic है, this is one fundamental equation for electrostatic and tells that there is current, there is charge, there is electric field. Second is B dot ds, Gauss theorem in magnetism is 0, and this equation tells that single pole does not exist. Like single charge exists, but single pole does not exist. Third is there integration, line integral of electric field equal to minus d phi b over dt. फेराडे लॉ, ये फेराडे में पूछ गया था. फेराडे d phi over dt induce EMF into potential difference multiplied distance give electric field. So electric field into distance equal to EMF. Faraday law. So this question tells us varying magnitude produces electric field. And fourth is this integration B dot dl equal to mu 0 into epsilon 0 d phi E over dt. Maxwell displacement. It tells that varying electric produces magnetic field. So using these, he mathematically proved that time varying electromagnetic arc, a type of waves are called electromagnetic waves. And then I will take them in next video. Thank you.